Hi and hello world. So now we are going to discuss the topic mechanical works. On the first few minutes, we are going to discuss the brief introduction, the definition of the mechanical works, the application, the scope, the mechanical engineering law, and the people involved in this work. So let's start with a brief introduction. So nowadays, the mechanicals are the main source in terms of innovations such as machines, automotives, refrigerators, gears, cars, and other types that supplies in everyday life that makes everyone to work easily. It also contributes to the economy and continues to invent any types of technology and obviously will improve every year until they create a new one. So as a civil engineering student, we can deal with advantages of having a mechanical as a part of the plan and also to consider the disadvantages so that we can determine the potential mistakes with further computation before it applies to the real construction. So in terms of its definition, the term mechanical means to produce any types of machines that can generate as a single device, either it is stationary or not. For as long as the engines or the machines can work, then it is also considered as a mechanical. In terms of estimation, the professionals can allow to compute the minimum number of mechanical utilities that fits in a respective plan or where the type of utilities can place based on the initial computations. So now we are going to have the application of mechanical works. So the mechanical works has several applications that are linked to the respective machines or engines and also has a major impact to the society. The following applications are the mechanical design, transportation system that is related to civil engineering, system dynamics and control, ground vehicle systems, and other applications that did not mentioned. All of the applications can greatly contribute to our society, including the economy, and still continues nowadays to innovate something that can people more comfortable than before. So with that, mechanical system in any building comprises heating system, cooling system, distribution system details, and fans that would certainly contribute a lot to the ease and comfort of the occupants. It also created to provide an environment that protects the structure and generates safe and healthy surrounding. Mechanical works is generally subcontracted out to mechanical specialties which prepare estimates for plumbing and heating, ventilation, and air conditioning system or what we call HVAC. So at this point, we will have the scope of the work. They have several types of works that can deal with the agreement so that can do their responsibilities as a worker and can perform until such time the plan is complete. For example, the mechanical contractor has a major role in terms of in charge for cooling system, piping, and or plumbing of the respective structures and will maintain those machines every day. Because of the potential risk regarding the technology, the mechanical contractor can regulate monitor those things that has a potential malfunctioning before they perform. The main purpose of having a scope of work is to perform based on the responsibilities under the contract and to follow the schedule based on the agreement. So now, let's talk about the mechanical engineering law or what we call RA 8495. This law contains several importance related to the mechanical engineering as of 1998. The purpose of having a law are to strictly follow the general guidelines and policies, especially the types of machines or engines that are applicable only in the Philippines. The main contents of mechanical engineering are under Article 4, Section 35 of RA 8495 stated that it is unlawful for any person to order or otherwise cause the fabrication, construction, erection, installation, or articulation of any mechanical equipment, machinery, or process for any mechanical works, projects, or plans unless the design plans, layouts, or specifications have been prepared by or under the responsible charge of and they duly assigned and sealed by a professional mechanical engineer. Simply, it means that The mechanical engineer will follow the guidelines and policies in terms of the mechanical project. Do not violate any sections of the law to avoid possible revocation as a licensed mechanical engineer. With that, mechanical engineer is responsible for monitoring and analyzing the mechanical problems that require alternative solution that involve in the construction site. So let's talk about the mechanical surveyor. The mechanical surveyor is responsible for estimating mechanical related problems with daily managed in terms of the machines or engines. Now we are going to have the master plumber. So the master plumber is responsible for installing the piping system and maintain in a clean way. The owner or the client. So the owner or the client is responsible for financing the whole project and can also monitor if they want. So, the design professionals naman is responsible for assessing the owner or client for the whole project, including the budget, project detail, schedule, and any types of contract documents that must be prepared. So, the design professionals are the architects, civil engineers, and for example. So, other design professionals are ECE, electrical engineer, and they are responsible for doing their designated position until the work is done, especially the mechanical work. So now we are done with the definition, the application, the mechanical engineering law, and the people or experts involved in our general topic called mechanical works. So now we will proceed to our main topic and one of the major system of this mechanical works called or named HVAC system.
Because the mechanical works has a huge scope, in this report, we are going to focus on heating, ventilating, and air conditioning systems or HVAC systems. Heating, ventilating, and air conditioning systems use mechanical means to cool, heat, clean, humidify, and replace air within a building. The general function of this is to control environmental factors in a specific structure, either for human comfort or the operation of the machines. It must provide acceptable indoor air quality and thermal comfort. To perform such work, energy sources of the systems include electrical, natural gas, coal, and/or oil, whereas heating and cooling media include water, air, steam, or chemical refrigerants. During the system design, the choices of energy source and heating and cooling media are based on the climate, building use, and local energy costs. Regardless of the design and its choices, each HVAC system usually consists of 5 basic components. So first component is the heating equipment. So as what the term says, heating, it generates heat to warm the building. It includes equipment such as electrical heaters, heat pumps, gas, and oil-fired unit heaters and boiler systems. So in the images shown, it shows the vent where heat comes out and the boiler system. Boiler systems could either utilize water or steam as a medium and electricity, gas, or oil as a source of energy. This would include pumps, piping, expansion tanks, terminal units, vents, and controls. The second basic component of an HVAC system is the cooling equipment. It removes excess heat of a building to cool it down. This would include water and air-cooled chillers and condensers, cooling towers, coils, piping, pumps, and controls. The images shows the most common HVAC system found in residential homes. So, mo na ni ang atong mga air conditioners or aircon sa balay. Cooling systems use water, air, and/or chemical refrigerants as a medium, and electricity as an energy source. Third component would be the air handling equipment. It moves conditioned air to the areas where it is needed in the building. This category includes ductwork, fan coil units, air handling units, VAV boxes, fans, dampers, duct heaters, and coils. So, to familiarize ourselves, here is what an air handling equipment or unit looks like. So, fourth item would be the exhaust systems. It generally removes air to help control fumes, odors, and smoke. Common exhaust systems are ductwork, exhaust fans, and ventilators. So the image shows an exhaust fan of an industrial chemical factory. Mo ni ang musuyop sa toxic na hangin to prevent people from inhaling it. Last but not the least basic component of an HVAC system is the piping. It is the means by which water, steam, and chemical refrigerants are distributed throughout the building. Piping systems include pipe, coupling, fittings, valves, and hangers. So the image shows here a water piping system. The same with civil engineers who provide structural plans and have their own symbols to certain items. Mechanical engineers and master plumbers have their own symbols in mechanical work or layout as well. So here are some of the symbols and abbreviations used in a mechanical work for the HVAC systems. It is important to identify these symbols when you are working in a construction project so that you will be able to understand its working details and technicalities. So there are two main types of HVAC systems on how they are being utilized. These are the residential and commercial HVAC systems. Residential HVAC systems are typically used in homes. The units are much smaller since it needs to cool or heat a smaller space as well. It is typically placed in the backyard or the sides of the house. It is a single pan and can be used for an entire draining system. HVAC units parts are split between the indoors and the outdoors, and it cannot be modified or expanded. It is manufactured as a standalone system. The equipment is not that large for small occupancies like residential. For the maintenance cost, it is not that expensive and can be done by the owner alone. So, for the commercial HVAC systems, the unit is larger as it needs to cool and heat a much larger space. The components are quite different as well, since it includes thermostats, condenser fans, compressor, evaporator, blower, and dampers. HVAC system is placed in the swamp coolers of the building's roof for great space saving and for no noise pollution. It needs to be more adaptable depending on the building where they are being installed. The complexity matters. It consists of multiple pipes and pans for the draining purpose to ensure complete evaporation and no overflowing. It is manufactured as a modular system. It is customized for effective heating and cooling and are very intensive. HVAC systems requires and need skilled and experienced technicians for maintenance with higher maintenance costs. So, the labor for HVAC systems, there are different types of workers involved in the system. So, for specific trades installation, we have the asbestos workers, usually involved in operations where pipe and ductwork insulation using asbestos-related materials and insulation of outside exposed surfaces of the air-conditioned spaces are carried out. Next is the boiler makers. These are needed to use all necessary tools and materials to install the boiler units of a heating system. Next is the insulation workers. These are needed in order to install the heat insulators such as insulating fiberboard, plasterboard, rock wool, and wood wool to insulate the pipes or ductwork that carry the air conditioning or heating media. So next is the plumbers. They perform variety of tasks including the shaping and fixing flexible metal roofing, cutting, bending, and joining water pipes, installing soil pipes and water systems, and sometimes gas pipes as well. So next are the plumbers. Plumbers perform variety of tasks including shaping and fixing flexible metal roofing, cutting, bending, and joining water pipes, installing soil pipes and water systems, and sometimes gas pipes as well. The usual metals they work in are copper, lead, iron, zinc, and mild steel. So the next worker involving in the HVAC system are the plumber helpers. They are usually required to help plumbers perform such work. Next are the sheet metal workers. So they are needed to shape sheet steel with a hammer or machines. Their job deals with joining sheets by riveting, seaming, welding, soldering, or brazing. They may be specialized as air duct makers, chimney coil makers, or ventilator makers. So, last but not the least are the stem fitters, or sometimes called as pipe fitters. So, they are required to install pipes for water, steam, gas, oil, or chemical plants. The pipes may be screwed, flanged, loose flange, or arc welded.
Technical drawings are the language engineers and architects use to communicate their ideas and designs to journeymen. It is a language based on lines and symbols that have specific meanings. Journeymen must possess the skill to interpret these symbols and lines so that they may install and maintain HVAC piping systems. Here are the examples of drawings or layouts for HVAC system. Figure 1 is the plan view of residential system. This figure depicts the planning of HVAC system for a residential building. This layout makes it easier to check if the spaces used for the system is suitable for its intended purpose. Figure 1.2 Isometric view of a residential system. It illustrates the 3D nature of the object. It helps in understanding the various elements needed in the construction of the piping system. Figure 1.3 is the supply air in a base cabinet, and figure 1.4 illustrates return air using framing members. This will be used to heat and cool the functional area of the building. Figure 1.5 is the radiant heating pipe layout. It is generally used as a layout of the HVAC system to distribute heat around a building. Lastly, Figure 2, A and B, is the typical HVAC layout plan. It clearly indicates the layout and mounting details of the HVAC system. Cost estimate for HVAC systems. Cost estimation is one of the most important steps in project management. A cost estimate at a given stage of project development represents a prediction provided on the basis of available data. Cost estimation for HVAC systems requires expert knowledge because most jobs are designed and laid out prior to the estimate. The mechanical contractor therefore needs to understand the heating loads and design a system to fit the required conditions before the estimating process takes place. To perform a detailed cost estimate for HVAC systems, the estimator must consider the following: materials, equipment, labor, and supplementary cost. The summation of these costs is the final total cost for HVAC systems. Here are the steps in estimating the cost for HVAC system. First is to study HVAC plans and specification. Make sure to understand the plans and how the HVAC system will come together. Next is to take off HVAC materials and compute materials cost. Record every product and supply needed in the HVAC system and make sure to double check the total quantities present. Identify each commercial cost to be able to determine the total cost of the materials. Third is to determine fixed equipment cost. The cost for HVAC machines and equipment like chillers, pumps, exchanger, heaters, fans, and collectors are estimated using assemblies cost where possible and actual load unit costs are necessary. Next is to compute for the labor cost. Labor expenses is determined by the cost of assemblies and units. The amount for labor cost is added to the total cost based on the number of working hours required to finish a single task. And lastly, estimate supplementary cost. To finalize HVAC system estimate, the cost of the additional works during the progress of original work should be added to the direct total cost.
Good day everyone. Today, we're going to solve a sample problem regarding radiant heating system under HVAC system. So the problem says, determine the piping needed for a radiant heating system for a 10-foot by 10-foot room. The pipe spacing is shown in the figure. Allow 40 feet of pipe to connect the pipe in the room to the other boiler. So this is the 10-foot by 10-foot room. The north wall, east wall, south wall, west wall. So in the given, the spacing between pipes is 12 inch or 1 foot on center. So this is the supply pipes. So the pipe here and the supply pipes, their distance is 6 inch. The pipe along south wall and the south wall is 6 inch, and the distance between the pipe along west wall and west wall is 6 inch, and here is 3 inch. So first, we need to determine the number of pipes that runs along north and south using this formula. Number is equal to distance over spacing. So this is 10 foot by 10 foot, right? So the distance here is 10, and the distance between this pipe and the wall is 6 inch or 0.5 feet, 0.5. And this is also here, this is also 0.5. So the distance between the west wall pipe and the east wall pipe is 9 feet, and the spacing which is given 12 inches or 1 foot. So the number of pipes to be used that runs along north and south is 9 pipes. So in the standard, The number of pipes that runs must be even number for the supply and return to enter the room at the same point. So, if the number of pipes calculated is odd, we must add 1 to make it even. Plus 1 pipe. So, the overall pipes that runs along north and south is 10. After that, we must determine the length of the pipes needed for this heating system. First, we must determine this bottom pipe. The bottom pipe, which runs along south wall, will begin to turn 1 foot away from west wall. So 1 foot, right? So the distance between these two is 6 inch. The 6 inch is 1 foot. So the distance here to here is 9 feet. That is the supply bottom pipe. Then we compute this bend. This is a 90-degree bend. So the radius is 6 inches or 0.5 feet. The 90-degree bend is equals to, so the formula of circumference is 2 pi r. This length is only a quarter, so we divide it by 4. 2 pi 0.5 over 4. The answer is 0.78 or 0.8 feet. So this is 9 feet plus 0.8 feet. Then after that we will compute the pipe that runs along west wall. So the radius is 6 inch. The pipe along west wall will begin 1 foot from the south wall, right? Because this is 0.5 inch and 0.5 feet plus 0.5 feet, so 1 foot. So we will start here. Then it will begin its turn 9 inches away from north wall, because this is 3 inch plus the radius 6 inch, so we will stop here. So we are going to get the length from here to here. So 10 feet, 10 minus 1 foot, 1, and 9 inches. So let's convert 9 over 12. So this length here is 8.25. This feet. So west wall pipe is equals to 8.25 feet. So we are finished here to here. Then this is a 180-degree bend, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 180-degree bend and another 90-degree bend. So we must compute this, the length here, 180-degree bend. Two pi r over 2 because it is half the circle, pi over 0.5. It is 1.57, or let's round it off, 1.60. So we have 9 180-degree bend, multiply it by 9, 14.4 feet. So we are finished here, 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 right? So the remaining pipes that needs to be computed, we are already finished here. Hence, the remaining pipes that needs to be computed are these 9 pipes plus another 90-degree bend pipe. In computing this is just simple subtraction. We have a distance of 9 inches here, or 0.75 feet, and 6 inches plus another 6 plus 6 is 1.5 feet. So 10 minus 0.75 minus 1.5, 7.75, the length of these 9 pipes. And another 90-degree bend for the return. We'll just copy this 0.80. And it says in the problem that we must allot 40 feet to connect the pipe in the room to the boiler. So we just sum it all up and we'll get the total length. Nine plus 0.8. There are two 0.8 plus 8.25 plus 14. Middle pipe, which is 9. There are 9 middle pipes. 7.75 times 9 plus 40. So the total length is 1 The total length is 143 feet. So we have our answer. That's it, guys. Thank you for watching. Subscribe.